In today's episode on the Do Roboti channel, I'll show you the entire process of how a Wienerberger ceramic block is made from this kind of clay, so watch until the end and let's get to work. With me is the plant manager, Martin. Welcome. And behind us is a huge mine. This is where it all begins. What does it look like here?
Yes, we're at the mine, an open pit mine. In front of us, we can see dump trucks and an excavator that loads clay onto those trucks. Then the trucks transport the material to stockpiles located right next to the plant. The mine has been operating for 18 years, and here we extract about 10,000 of these truckloads per year.
If we convert that to, for example, the number of houses built, which I think viewers can best imagine, how many houses could we build daily from the clay we extract here?
Every day we produce enough for about 30 houses.
We're able to produce enough blocks for 30 houses from the daily output and from this kind of clay. This is one of the materials that's extracted here. The rest is brought in from external suppliers, right?
Yes. The main raw material is, of course, clay from our own deposits, but we also add sand and sawdust, which we mix during the initial processing. We'll see that in the next stage.
Of course, we'll go to the plant in a moment and show that, but while we're here and we can see the extraction behind us. Is this extraction continuous? Is it done in 3 shifts, or do we only extract during the day, or are there specific extraction periods?
Yes, we extract during the day and in the period from spring to autumn, because clay has the property that during rain it gets soggy and it's slippery at the mine, and then we simply can't let vehicles in for safety reasons.
Okay, so you have to collect enough of it during the spring and autumn period so that it lasts for production throughout the whole year?
Yes, exactly. Then we store it in piles, and throughout the year we take it from those piles.
I also wanted to ask how this factory was established here in the first place. Was there a mine first, then the factory? Or were there some excavations done here that revealed this valuable clay in this particular place? Yes.
No, the clay deposits had been known for many years to be located here. Of course, Wienerberger also examined our deposits here, and after purchasing these deposits, the decision was made to build the plant right here in this location. There was just an open field here. There were no factories before, no brickyard. It was only here that we were established and we produced ceramic blocks.
Exactly. Usually in construction, let's say, this kind of clay is undesirable because it has to be removed and replaced with some other material, but here it's precious. And in this video, we'll show you how these blocks are made from it. So shall we move on?
Yes, I think so.
When I was a kid digging in the sandbox, clay always reminded me of something wet and moist that you could mold, but here you can see it's definitely dry. Is this how clay is supposed to look?
Yes, the layers we see here are extracted from about 20-something meters deep. This clay is actually dry. It has about 20% moisture, and to properly homogenize and plasticize it later, we have to add water. And we recover water here in the same way from the mine, where we recover about 3,000 cubic meters of water annually from our own source.
And do you use it in production?
Yes, exactly.
So, is the moisture of this clay that's extracted here always the same, that it's always this dry? Yes, it is.
It's similar, around 19 to 21%, right? You could say it's the same.
And for how many more years do you know you'll have this clay here to extract and that production will continue at this factory? Well,
the deposits are very large. We have at least 50 years worth of clay deposits here.
so that's 30 houses a day. You can do the math and write in the comments how many more houses can be built from this clay mine. 50 years and 30 houses a day. Go leave your comment now and we're almost entering the plant. We're at the stockpile, and this is the one stored here last year, right?
Built, yes.
Built, so the new stockpile is being built on the other side.
Yes, exactly.
Does how it's arranged in layers matter?
Yes, the stockpile is built carefully to maintain the proper material quality. The laboratory makes sure to examine every layer, check the granulometry, and based on that, we know what material we have for the next stage of production.
Okay, so everything that arrives here is stored Let's say all the clay that is extracted is stored here, but it is only examined in the next stage.
It is tested while the stockpile is being built. In general, each layer is about 30 centimeters thick, and the lab takes samples from specific points and tests the clay. Based on that, we create a map and check the quality of the material in this stockpile.
Okay, so now when the operator uses the loader to take this material, he knows exactly what will be loaded into the factory.
Yes, and later the entire material, this mixture, is also tested by the laboratory where we check the quality of this material. Thanks to this, we can also know the quality of the material in the next stages of production, and this is very important for us.
Exactly, that's what I wanted to highlight, because if we look at a coal mine, the coal will be burned anyway. Here you could say that, for example, each batch of this porotherm will be different because one comes from a depth of 20 meters and another from a depth of 25 meters, right? Yes.
Yes, and here the laboratory plays a very important role in selecting the right mix so that the final material is of the right quality.
And always the same?
Always the same, yes.
Is the aging time of this clay also important here? Or could it be used immediately after being extracted directly from the mine?
Of course, the aging time is very important. We age the clay for at least 6 months to ensure it has the best possible conditions so it can overwinter, and then we can be sure that the quality of the material is appropriate.
Sure. Here we've moved to the place where these ingredients are loaded into the factory for full production. What do we have here besides this stored clay and your product?
Clay is our main product, but we also add other raw materials such as sand and sawdust. We obtain them from local suppliers, from sawmills, the sawdust, right? And then the loader's task is to load these raw materials into the feeders. The feeders dispense this material at the right speed onto the conveyors and then further on to the initial processing.
Music will discuss this shortly. Clay and sand make sense to me being in the blocks, but sawdust is interesting. However, we won't reveal that just yet. We'll talk about it during the actual production because I think it's really interesting why there's sawdust in the blocks, right? You mentioned those ingredients, but I also see a big silo here. What is stored here?
Music. Here is the waste from grinding. Because our blocks are ground, we produce porotherm dry fix blocks, and the excess material that is ground is transported pneumatically right into the silo. Then, as a form of recycling, we add it to our mixture.
Music. Are there any other ingredients that you also don't waste and are later used? Yes.
The waste from the press, which is a byproduct created during production on the press, and we also add dry waste from the setup.
Music. So nothing goes to waste? That's also valuable information that everything is further processed in recycling. Yes, exactly.
Music.
We didn't keep you waiting long with this fun fact, but we already have the sawdust in our hands. Here it was brought in by a loader. What happens in this room?
Music. We are at the sawdust processing area. As you mentioned, the loader loaded the sawdust into the dirty sawdust feeder. At this stage, we sift the sawdust to achieve the right granulation of the sawdust. Any waste that comes from external suppliers, like small pieces of boards, is ground up and added at the next stage to the mixture. All right.
Music. But we still don't know why sawdust is added to the mixture, that is, to the block. Are these sawdust houses?
Music. No, as the name suggests, our block is called porotherm, which means the sawdust burns out and creates pores, giving the wall better thermal properties.
Music. In the past, a brick was simply clay with no pores and basic thermal properties, but porotherm has better thermal properties.
Exactly, music. We are at the preliminary processing stage, where we mix all the ingredients needed to produce the mixture for our hollow brick. Behind this hall, we have feeders where the loader loads the material. Then, the material lands on the grouping conveyor belt and is fed further to the roller crusher. We add water to achieve the right moisture and plasticity. The roller crusher presses the clay, the entire mixture, through perforated screens. Then the mixture goes to the preliminary rollers, the precision rollers, and then to the mixer. All these stages of production are meant to homogenize the mixture to get rid of any dry material marl which could later cause problems in the next stages of production. We have magnets that catch unwanted metal, which would be a problem in the next stages of production, and which actually comes in with the deliveries of raw materials from outside.
And here, once the material has been mixed by all these machines together with the water into a plastic mass, where does it end up?
It then ends up in the storage pit by means of a belt conveyor, and we fill the pit where we store our mixture for the appropriate aging period.
The storage pit, meaning the storage of the material we previously mixed. Why is it stored here and not sent directly to production?
First of all, the storage pit serves as a warehouse for the next stage of production, but in addition, the mixture is homogenized here, it gains the right properties, and the moisture content becomes uniform. There are 4 compartments in the storage pit. In each compartment, we have enough material stored for about 1 day of production, so you could say that here we have fresh material for about 3 days, 3 to 4 days at most. We have a bucket excavator which is operated from the next station from the forming area depending on the needs. The material is collected, the operator sets the right pace for it, and it's transported to the next station.
So is the next station the forming process?
Exactly.
Let's go see how these hollow blocks are made. Even before the actual forming of these hollow blocks, I see a really interesting machine here. What's happening behind us?
Here we have a screening machine. At this stage, we add water to properly plasticize the mixture, and additionally, through these sieves, we get rid of any dry material or possible lumps of dry material so that they don't cause problems in the next stage of production.
And then what? It goes further on the conveyor belt continuously, and now we move on to the most interesting part, in my opinion, which is the actual forming of these hollow blocks.
Yes, this is really the heart of our plant, where we form these hollow blocks using a press and a die, which gives them their shape.
We've already gone through several stages, and besides the operators of loaders, excavators, and dump trucks, there aren't many people here. Is this system really that highly automated?
Yes, the system is highly automated. This is one of the most modern plants in our company. We have 12 robots that support our work. Thanks to this, we can be so efficient.
Okay, so there are employees, but as I can see in these boxes, they are operators of these robots or machines, but personally they don't have to knead, make, or mix anything themselves.
Exactly. They control the process, supervise it to make sure it runs according to the guidelines and proper parameters, so that the final product is of the right quality.
We're now with Mr. Jacek, the press operator. Hello and welcome. Lots of buttons, lots of screens. Nowadays, an operator is not really by the machine anymore, but rather in a control booth like this. What's happening here?
Yes. Here we have a highly automated production line, and at this station, we take measurements according to the specifications we have for a given product.
So, is it predetermined what will be produced today? Let's say we have it written down on some checklist here that this specific product in these specific dimensions is to be made, and you control that?
That is, yes, in the PCPCS, we have information about which product will be produced on a given day. We start by possibly changing the format, the first move with the machine, to see if everything is working, and then the whole production of everything begins.
As we can see here, this happens automatically. What could go wrong so that, I don't know, suddenly you would have to do something during the day that is unpredictable?
The unpredictable thing could be a wire snapping, which would cause the brick we're producing now to lose its angle, and it would simply be a loss for the plant.
So, do you have to keep checking it all the time?
Yes, check the cuts to ensure they're not in the middle of the brick, especially on the outer edge, as that's not allowed by the specifications. There's always something to do, like quality measurements, safety inspections. We have to check all the safety measures to make sure there are no accidents here. Here, if something, as I said, breaks, then you can't fix it anymore.
Something else will burn out. Thanks, let's move on.
Good luck.
The next stage here, it's not mixing anymore, but making this block, right? What's happening here?
So actually, it's production and mixing at the initial stage. We also have a double shaft mixer that further mixes the mixture. We add steam to the mixture to make it more uniform and plastic, and then we push it out. Using the screws, the press cylinder, and the die, we give the product its final shape.
But it's still so soft, is that normal?
Yes, it's still in a plastic state here, so the block only becomes hard in the next stages during drying.
And I have a question here, because your company produces different blocks with slightly different formats. Does the composition of the mixture also change, for example?
Depending on the format, we have different prepared mixture recipes. The laboratory prepares the appropriate recipe for the specific format depending on quality criteria, conditions, and drying recipes. So many factors influence what final ingredient goes into the mixture. Okay? This is the so-called extruder. The extruder gives the shape and the cutter cuts the block to the appropriate length. Of course, at this stage, we have to account for the shrinkage of the block in the next stages. In the production stages, it is made longer because it simply shrinks in the dryer.
You can see the automation here all the time. Everything runs like clockwork. We already have the finished product, almost finished because it's a formed product, but now it goes to the dryer.
We are at the pallet transport, the carts where we load the formed hollow bricks, our semi-finished product. First, they go onto the drying carts, and then they're transported to the dryer. In the dryer, we evaporate the water. When the hollow brick enters, it has about 20-something% moisture, and after it leaves, it has about 1% moisture. So we evaporate several thousand kilograms of water during the drying process, per hour, of course.
How long does this drying take?
It takes between 10 and 12 hours. The dryer is about 100 meters long, and every cart that is pushed into the dryer causes a dried cart to come out. We dry these bricks independently in 4 separate channels. The air we use for drying comes from the kiln, from the cooling zone, and from outside here from the production hall, and we also use air from behind the building.
And that's right, dear viewers. If you're watching this material on your TV, with your partner, with your children, with friends, with anyone, please take out your phone and leave a like and a comment on this video. I know it's hard on the TV, that's why click on your phone. We will be very grateful for all those likes under this material. And of course, watch until the very end and we'll move on. We've just seen the drying room, and visually, you can't tell they've lost 20% of their water or look any different. What happens next and how does it work? Thanks.
We're now at what's called the staging station, where we transfer the semi-finished product from the drying carts to the kiln carts. At this stage, the moisture content of the brick is important, so that, as you said, it drops by that 20% and finally reaches about 1%.
If the moisture content isn't right, what happens to the hollow brick?
The hollow brick can crack in the kiln, it can get damaged, chips can form, so that's why this is a very important stage, drying to remove the right amount of moisture at the right time.
Okay, but if we notice that it has some moisture it shouldn't have, then it goes back for recycling.
Exactly.
And here at several stages, let's say in the factory, we've seen that some blocks fall down somewhere, they're badly formed and so on. Nothing happens to them, they're simply reprocessed.
Yes, we add all these semi-finished products at the preliminary processing stage.
Okay, that's what we showed at the very beginning of the episode. So now that we've sorted and arranged it, it's time for the oven.
Exactly. The brick goes into the gas-fired tunnel kiln, which is up to 160 meters long.
Let's check it out up close. Interesting. It looks like already fired hollow bricks. What kind of cart is this?
This is a kiln cart, where we place the hollow bricks after they've been dried. It's made of refractory materials and it circulates around during kiln transport here at the setting machine. Then it goes through the kiln, unloading, and the kiln just repeats these cycles.
And on this, let's say we set the hollow bricks that we see here before firing.
Exactly.
Now we're above this kiln, right?
Above the kiln, we now have 900 degrees under our feet. You can feel the temperature, it's warm. And these big pipes we have here, this is actually the recovery of hot heat from the kiln, which is transported to the dryer to dry the bricks. So we recover it, we don't waste it, we use it to dry the products.
And the kilns are powered by gas.
Yes, the kilns are powered by gas.
Now we are above the kiln, and with me is Pavel, a specialist in drying and firing. Welcome.
Hi, welcome.
Share some interesting facts about the firing process. We've just loaded these hollow bricks onto carts heading into the kiln, so viewers are curious about what happens next.
What happens next? The carts move along the tracks, then they are moved by a transfer cart to the kiln. Where do they enter the kiln? In the first stage, they go into the airlock. Here on the diagram, we can see a visualization of our kiln, and the carts are entering the airlock. Where then, with each movement, do they move deeper into the kiln? In the kiln, we have 15 HG burner sections and 16 SB burner sections, which let us properly control the temperature and firing process. For each brick size, we have a specific firing program prepared. Here we can see the course, the actual progress of the firing process, and we check if everything is proceeding correctly. The entire technological process takes about 18 to 19 hours, between 17 and 19 hours, depending on the format. The firing temperature is about 900 degrees. As you've probably already noticed, we have a viewing port where you saw that the brick simply glows there. It's hot, it's hot.
So first we dry the brick for 12 hours, and then we fire it for another 18 to 19 hours.
Yes, then there's the firing, after which it comes out of the kiln and moves on to the next stage. You'll see it here. You'll go to the unloading area where there's also a cooling channel. Where else? We recover the heat from those carts and then transport it to the dryer to increase our thermal efficiency, right?
What does your work here look like? Is it just monitoring the temperatures and the whole process? Or do you also, I don't know, maintain the kilns, go inside them, or maybe shut them down for a while? How does that process work?
The kilns are also shut down. Our last shutdown was about 2 years ago. During that time, we do maintenance inside. However, the main work is constantly monitoring, checking, cleaning, adjusting burners, and overseeing the entire process and its parameters.
The kiln was shut down 2 years ago, so does it operate 24 hours a day?
It operates 24 hours a day, and that was the only shutdown in 17 years.
Okay, so it's similar to the furnaces in a glassworks, but there the reason is that the glass inside could solidify, so they don't shut it down. But here, why don't you shut down the kiln?
The kiln isn't shut down because it's a complex technological process. Shutting it down takes about 7 to 14 days, and then starting it up again also takes a long time. It's a complicated operation.
Okay, so it's better not to do that. It's better to take care of everything on an ongoing basis so that you don't
Have to do it. We take care of it.
And I'm also curious, and probably the viewers are too, we've seen, let's say, those clay-colored blocks coming in. What happens that makes them change color like that in the kiln?
We have a temperature chart. The color change happens through firing at those high temperatures, 900 degrees, where all the compounds are completely burned out, and what we have left is ceramic material.
Ceramics from this clay are made by firing at high temperatures, correct? I think you understood that, dear viewers, and I definitely did here at this computer. So the clay color changes precisely because of those high temperatures and burning out everything inside, and that's how the color changes. Write in the comments if you understood. I think you did, because the gentleman here explained it quite well. So let's go see what this brick looks like in its fired color. Wygląda. Now we're at the very end of this kiln. We fired these hollow bricks, and just a moment ago we talked about the whole technology, but the question also comes up, why do we even fire it? What's the point of firing the hollow brick at 900 degrees?
During those dozen or so hours, the soft clay that's used during forming actually turns into a completely different material. A material that is very strong, very durable, and resistant to all kinds of weather conditions. We could drive a pallet into the kiln and take it out within an hour. The organic material inside would burn out, everything would be fine, but as a result, we would just get crushed ceramic material. We need this block to be in one piece so that it can later serve its intended function on the construction site.
Intended function meaning what exactly? How can we compare it to other products that are also used to build houses, that also have their own composition?
That's a very good question, because in fact ceramic material, a ceramic block, is the only product on the market that is fired. Competing products, for example aerated concrete, are made in so-called autoclaves. This is a process where there is very high air humidity, and in fact this product is steamed. As a result, at the end of the process we get a material that is moist. In this case, we get a ceramic material that is fired, which immediately meets all the requirements we set for buildings. Therefore, we do not introduce water into the walls. If the walls are damp, mold forms on their surface. Mold releases mycotoxins, which are extremely dangerous for us as humans. However, if we have a hollow block that has just come out of the firing process, which is free of physically and chemically bound water, it is 100% dry. We can be sure that after being built into the wall, the entire building structure will immediately meet all the requirements. Strength, thermal, and acoustic functions, this house will be healthy and warm.
So, aerated concrete, which we most often use for partition walls and similar things, is a material that isn't completely dry, and the moisture still remains in it all the time. With this product, there is no such moisture because we know that after the drying process, the moisture content is down to about 1%, and after firing, there's even less water inside, which means it's a much safer product for construction.
It definitely is. It's a much safer product, even when comparing the strength parameters of these products. Behind you is a product with a 15 MPa class, which means that to crush this product, we would need about 200 tons. This class 15 is for comparison with aerated concrete. In aerated concrete, the average strength is around 3 to 4 MPa, which is a completely different strength class.
And honestly, I'm really shocked that these products can differ so much. Thank you very much for explaining to our viewers why this whole firing process took place. Beautiful hollow blocks, still warm, came out of the kiln. They cooled down there, they're cooling, but we also have another process going on here behind us. Robots, lots of robots. What are they making here?
We have an unloading station where these robots unload the fired bricks onto a conveyor belt, and the conveyor belt delivers the bricks to the grinders. They are ground to make the bricklayer's job easier later on. We don't need standard mortar then, meaning sand, a concrete mixer, or water. Instead, we have an easy method of bricklaying using a special foam adhesive, which the bricklayer applies with a gun. That's right.
We haven't done this kind of thing on the channel yet, so if you're curious, and if you're watching this material right now, you probably recognize this method of setting blocks with foam. But if you'd like to see how I use these hands to apply the foam and how you build a wall with something like this, I'd be happy to show it, so leave lots of comments. Comments about showing the work of a modern bricklayer, because that's what you can call him, and then we'll record it and make it based on these blocks. We'll arrange them. Today we produced it, and in the next episode we can build something out of all this, so I'm counting on your comments. We're sanding here behind us, and what's next?
The sanded product is exactly 249 millimeters, which makes it very easy for the bricklayer to build precisely. After sanding, the blocks go onto a conveyor belt where they are picked up by robots onto pallets, strapped and palletized. The bricks are moved under the wrapping machine where we put on the packaging and label them, and then the product goes to the warehouse.
You can build 30 houses a day with these blocks here. That's a huge amount. I don't know who lives in all those houses, but you can see that it keeps selling all the time because production never stops. Exactly.
I would also add that at every stage of production, the machine operators are responsible for maintaining the quality of the product. They carry out tests for dimensions, strength, and moisture, and that allows us to keep the product at the highest possible quality.
Firing the product and creating it from scratch is one thing, but it's also important what kind of strength it has and what classification it gets. What happens here in your laboratory?
We are in a room where we perform compressive strength measurements. This is one of the basic analyses that allows us to classify products based on their strength. We will be compressing the PTH 25500 format. The declared strength of this format is strength class 15.
Okay, and is this checked randomly, or how does it work?
That you bring one here, let's say. According to the factory production control system, we perform this test regularly.
Okay, so you'll show us how it happens so we can see it for ourselves. We close this machine. Okay.
Yes. We place the test specimen in the test chamber, then we move to the machine's control panel. We enter the dimensions here, length and width, which determine the area affected by the force, right? Then, after entering this data, we move on to the measurement, which means we press the start button. At this point, the machine adjusts the distance between the plates, meaning the plates of the testing machine come into contact with the pressure surface. This takes a few minutes, and then the process of gradual crushing and increasing pressure force will simply occur.
Right? How long does such a process take?
Up to about a minute, I think. Okay.
Okay, but we compress this element until it falls apart completely.
Yes, we compress it until it completely falls apart, let's say until the block explodes in the machine.
Okay, and then we know that up to that point, it held up to that point?
Yes, exactly. The pressure at which the element was destroyed is the actual target strength that our element can really withstand.
So after this measurement, as we can see here, the block exploded, a very cool effect, but I think it met the standards as I can see here on this screen. Yes.
Our block met our requirements in terms of strength results. We got a result that can be compared or can be described as a compressive force of about 200 tons on the block.
200 tons on the block, that's how much it withstood, and only at that point did it break. 200 tons is quite a lot, yes.
That fully meets the requirements when it comes to strength class 15.
After the strength test of this product, we move to another laboratory. It looks very chemistry focused in here. What do you check here?
We are in one of the company laboratories of Wienerberger. This is a laboratory where we carry out a range of analyses of raw materials and semi-finished products for the production of ceramic blocks in accordance with the factory production control system used at our company. The purpose of this system is to ensure that the products we manufacture, the finished product, meet the requirements for Type P first category ceramic building products, in accordance with the requirements of the declared performance properties, as well as the requirements of the PNEN 771-1 standard related standards and national technical specifications.
And here in the laboratory, both the ladies and gentlemen work to ensure that these standards are maintained and also that the material taken from the mine is used in the best possible way for firing the finished product.
Yes, exactly. Our goal here is to find a kind of balance, to strike a middle ground among all the parameters of the production mix. In this way, on one hand, we achieve a composition of raw materials with the right energy properties, and on the other hand, we manage to reduce the emission of harmful greenhouse gases. Yes. The plants are supervised by the Polish Center for Testing and Certification, and we have a plant certificate. It is intended for factory production control for masonry elements, first category Type P wall elements, intended for masonry in protected walls and masonry structures, protected walls, partition walls, and blocks. Sure, I understand.
Before packing all of this onto the trucks, do we need to shrink wrap it and strap it?
Exactly. Right after the robots place the bricks on the pallets are transported to the wrapping machine, which packs the products to protect them from weather conditions. And then we have the labeling machine, which sticks a label on the product with our product parameters.
Earlier we mentioned how many of these products are made here per day, but how many trucks take them out for sale each day?
It's about 60 trucks.
60 trucks today. I immediately noticed there are definitely more.
Well, it's springtime, which is good for construction, so there are clearly more trucks today.
Okay, so my dear friends, let's move on. The production process here is finished, so now we need to build something. My dear friends, as you can see behind me, a lot of trucks are leaving with this product for the customers. We also have a pallet prepared here, just like I mentioned to you earlier. If you would like to see how this product is laid directly at the construction site, if you want to see what the work of a modern bricklayer looks like, where these blocks are glued with foam adhesive, be sure to write it in the comments. Together with Wienerberger, we will try to show how these blocks are actually laid, so leave your comments and we will try to make another episode. On the construction site with the bricklayers, so like and subscribe to the channel. Let's get to work.